All right, special functions. So the first special function we're going to talk about are piecewise functions. So functions whose graphs resemble stair steps are known as step functions. This is one of these examples of a piecewise function, which is different pieces. Have you guys seen a function that does that, like looks like stair steps? No. Most people haven't. And this is called the step function or the greatest integer function. Okay, it's represented by f of x equals the greatest integer function of x. So see how it's those fancy brackets? Kind of like your real numbers have the extra little line. It's kind of like brackets, but with the extra line. All right, so what this means is the greatest integer less than or equal to x. Okay, and it's kind of confusing when you first learn it, so let's see if we can figure it out. So let's start with 0. What is the greatest integer less than or equal to 0? 0. Less than or equal to, right? 0 is bigger than -1. All right, how about 0.5? What is the greatest integer less than or equal to 0.5? 0. Less than 0.5, right? Integers are those whole steps. They don't include the fractional parts between. All right, if I have 0.9, what is the greatest integer less than or equal to 0.9? 0. Even if I had 0.99, that would still round down to 0. So anything between 0 and 1 is going to be 0 for the y value. So it's just that horizontal line right there. But then all of a sudden we get to 1. The greatest integer less than or equal to 1 is what? 1. And then you can continue. 1.5 would be 1. You're always rounding down to 1. So then we have this horizontal line there. Do you guys see where I'm drawing? I'll draw it in red. Okay, but then I get to 2. So all of those are there. So 2, 2.1, 2.2. All of those round down to 2. This is like the rounding down function. Looks like that. Now what about on the endpoints? So when I had 0, I got 0 out. But then when I plugged in 1, I didn't get 0, I got 1. So the points on the left are filled in, the points on the right are open. It's kind of hard to see with my graph. Let me go to full screen. So filled in on the left, open on the right.
So are they?
Okay, let's try some more. So I'm still seeing you guys confused. Okay, what if I had 3? What's the greatest integer less than or equal to 3? 3. Anything between 3 and 4 will round down to 3. So here's where 3 was. Anything between 3 and 4 rounds down to 3. That's why it's right there. But then once you get to 4, it jumps up to the next step. Okay, now let's try negatives. Let's say I was at negative 1.2. What's the greatest integer less than or equal to negative 1.2? Negative 2, you guys are good, yeah. Because here's where negative 1 is, here's negative 2. If I'm at negative 1.2, I'm going to round down to negative 2. So basically the steps continue, just like you would think they would.
But they're not connected.
They're not connected, right? Okay, so so the one we just did was negative 1.2 right there. It went down to negative 2. So that's why its height, its y value is negative 2. All right, weird, isn't it? All right, but we use these all the time. The big thing is parking garages use it. So have you guys gone to like the mall parking at Circle Center and you know like 0 to 3 hours is, I forget, it's like really cheap. Like $3. Okay, but then after that they're charging you like $2 per hour. So sometimes you're like driving through and you're like, okay, I have to get there at 4:11. At 4:11, that's my 3 hours. And then you get stuck in this line and you're stuck forever. And it's 4:14 when you go by. And you're like, but it was only 3 minutes ago. Why are you going to charge me an extra $2? Well, that was a step function. function. It's a certain flat rate for the first 3 hours. After that, the next hour is a flat rate. After that, it's a flat rate. These are step functions. Does that make sense? Okay, so the next one says, one psychologist charges for counseling sessions at the rate of $85 per hour or any fraction thereof. So if you go a minute over, they're going to charge you for that second hour because they're busy. They got to go and see their other patients. So draw a graph that represents this situation. Okay, so between 0 and 1 hours, how much is it costing?
$85.
Yeah. So it's that flat rate of $85. Once you get past 1 hour, so 1 hour and 1 minute, you bump up to 170, right? Okay, think about the endpoints on this one. Is it like the step function? Are they filled in on the left and open on the right? What do they look like? So what if you went for exactly 1 hour? How much would they charge you? 85. So exactly 1 hour needs to be filled in. Once you get to 1 hour, it's open. Or once you get past 1 hour, it's 170. All right, so they're filled in on the right in this case. What about at 0?
Oh, they would charge me.
Yeah, 0, 0. That would be that point there. And obviously you can't have a negative number of hours. So your graph's looking something like that. So you can continue with the steps. All right, now notice I said it's a function. Remember last time we talked about functions and we talked about the vertical line test? Does this pass the vertical line test?
Yeah.
Yes, why, Ryan? Guys.
Because the left one there open.
Yep. So yeah, if you take vertical lines through it, yeah, they're crossing at those points, but one of them's open and one of them's closed. So there's only one point that it's actually hitting at that, on that vertical line. Does that make sense? So it's a function. So you can always check to see if it's a function. All right, next up. All right, so constant function. So any equation of the form f of x equals b. So think of numbers. If f of x equals 5, well, we talked about f of x is your y value. So if y equals 5, so Alex Nearmore, if y equals 5, so if I have the equation y equals 5, is that a vertical line, a horizontal line? Horizontal, right? So a constant function is going to be a horizontal line through that y value. So it's going to look like this. And then b is wherever the height is. So a constant function is a horizontal line. Identity function, that's of the form f of x equals x. Well, if I have f of x equals x, that's y equals x. Right, f of x is y. That's y equals 1x plus 0. So you go to 0, 0, you plot your first point. You go up 1, right 1. Up 1, right 1. You could also go down 1, left 1. This is what the identity function looks like. Now we call it the identity function because each point, the x value looks like the y value. 2, 2, 1, 1, 0, 0, negative 1, negative 1. Make sense? Pi, pi.
So y equals negative x would be a negative 1.
It would be going downwards, yep.
What
Alright.
is it if it's like a vertical line?
If it's a vertical line, then it's not a function, right?
Oh, yeah.
Tricky. Then it's x equals. All right, absolute value function. The absolute value function forms a V shape. Do you guys talk about absolute values in Algebra 1?
Yes.
Maybe. All right, some of you guys do. All right, x and y. So if y is equal to the absolute value of x, let's plug in points. Let's try negative 2, negative 1, 0, 1, and 2. If I take the absolute value of negative 2, what do you get? 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So I'm going to have the point negative 2, positive 2. The point negative 1, positive 1, 0, 0. Then I'm going to have 1, 1, 2, 2. So it goes back up. So it's not making a line. It's making the V shape. It's always a V, not a U like a parabola. So it's a V shape for absolute value. All right, so example 1, graph g of x equals -3. So that's y equals -3. So y equals -3, go down to -3. It's just that horizontal line. All right, h of x equals absolute value of x minus 3. This is a little bit harder, so let's do a t-table and see what it looks like. What number can I plug in to get the smallest number possible out? 0 would give me -3 in absolute values, which gives me 3. 3. Okay, when that happens, make that like your middle point. So I'm going to do 3, 2, 1, and then I'm going to try like 4 and 5 as well. That will kind of give you a clue what your x's should be. It's okay if you don't. It's just going to tell you where your b is with the absolute value. All right, so I'm going to do 1 minus 3 in absolute values, so I get 2, right? 2 minus 3 in absolute values gives 1. 3 minus 3 in absolute values is 0, 1, and 2, right? See how it's symmetric? Okay, so I have I have 1, 2. I have 2, 1, 3, 0, and then it pops back up, 4, 1, 5, 2. If you tried negative numbers, that'd be fine. Like a lot of you guys would have tried -1. -1 is going to give me +4.
When you graph those, you have to have like the point of the b.
Yeah, if you guys had only tried like -2, -1, 0, 1, and 2, you wouldn't have gotten the point of the v. So your graph would look like a line. So make sure that you know that it's popping back up. If you have an absolute value, there should always be a place where it pops back up. It makes the v. The v's can also be upside down too. That's when you have like a negative absolute value of x. That would mean that it would be upside down then. All right, you guys try number 3. So graph j of x equals the absolute value of x minus 1. All right, so for our graph, so you guys have the t-table. I think most of you guys had the t-table right, but graphing the points messed up. So if you plug in 0, you have the absolute value of 0 minus 1, so -1. So that's one of your points. So even though you had the absolute value in your problem, you still got a negative. This is the -1 part. All right, so if I plug in 1, I have absolute value of 1 is 1, minus 1 is 0. If I plug in 2, I get 1. 3, I get 2. Try some negatives as well. When I plug in -1, I get 1 minus 1, so I get 0. -2, I get 2 minus 1, which is 1. So as long as you have points where you have the same y values, like I had 0 there and 0 here, you're going to get the v. So you should be able to see the v at that point. Okay, so I have 0, -1, 1, 0, 2, 1, 3, 2, -1, 0, -2, 1. There's your v. So if I was checking this on your homework or anything, I would definitely look for that point 0, -1. So for the v, the vertex. All right. Okay, so this is leading to what we're calling the piecewise function. So we talked about the step function, the absolute value function. A piecewise function you don't have to draw this, but it's basically going to look like you're going to have one piece that's going to do something, another piece, oh, I'll make it open, and then you could have a third piece. I mean, you can have an infinite number of pieces, and that is a function because it passes the vertical line test. There's just different pieces. That's why it's piecewise function. All right, so we're going to actually graph this. Now it says the absolute value function can be written as -x when x is less than 0. So think about when x is less than 0. That's over on this side. So when x is less than 0, you're just going to have -x, which looks like that. When x is greater than or equal to 0, so on the right side of our grid, you're going to have just positive x. So y equals x, look like that. That's how you got the absolute value function. It was 2 pieces. Okay, so number 1, sketch the graph of the function. So it's saying when x is less than or equal to 1. So don't draw this, but here's the section of our graph that we're talking about, just so you can see. In this red rectangle, we're going to draw the line 2x plus 1. So y equals 2x plus 1. But I'm not going to go past the red rectangle. I'm only going to stay in that red rectangle. Okay. So I have y equals 2x plus 1. Think about what y equals 2x plus 1 looks like. You'd have a y-intercept of 1. You'd go up to right 1, down to left 1. Right? You could do that. Oh, I'm doing it wrong. I know I'm right. Okay. So this would be our part of the function. Does that make sense? Now in my green rectangle, I'm going to draw the second part. I'll show you an easier way to do this in a second. So if I have x squared when x is greater than 1, so x is greater than 1 is my green rectangle. In that green rectangle, I'm going to have another function. So it's going to look like x squared.
We have to put boxes.
No. So if I have x squared, that has the point 0, 0. It has the point 1, 1. It has 2, 4, 3, 9. And it creates a parabola shape. Those are the two pieces. So you have something where you have a line, and then you have a parabola shape. Mine doesn't really look like a parabola shape. It looks kind of like a line. All right, what about open and closed? So on the one that I circled in red, 2x plus 1, is my endpoint going to be open or closed?
Close.
Closed. Why, Ryan?
This is 4 equals 2.
Yep, and then the green one is going to be open, so that's going to be open there. So right there, you're going to have an open. Okay, now I'm going to delete. Erase, 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 and now I'm going to show you the easy way to do these. If you're really good at your piecewise functions, you can do it that way. You can just think about, okay, on this side, this is what I'm going to have. On this side, this is what I'm going to have. But when people are first learning, I've found that the easiest way for people to learn is to do separate t-tables. So the first one says it's only when x values are less than or equal to 1. You're going to have x values, and you're going to get y values are 2x plus 1. Okay, so let's just talk about that piece. So if I want less than or equal to 1, I'm going to move that one over. That means I want to pick one, and I know it's going to be a closed circle because it was less than or equal to, right? I also want to pick other values that are less than or equal to 1, so like 0, -1, -2, all those different things. Think about what numbers you get out. If I plug in 1 to my 2x plus 1, I get 3. If I plug in 0, I get 1. If I plug in -1, I get -1. If I plug in -2, I get -3. Let's graph just this piece. So I'm going to graph it in red. So I'm going to have 1, 3, and it's going to be filled in. I'm going to have 0, 1, -1, -1, -2, -3. I know it's a line, so it looks like that.
So basically it's just like you're graphing two different things,
Mm-hmm.
but you have to cut them off.
Yep, you're graphing two different things, so you have to cut them off at certain points. So I did not extend my arrow to the right because I didn't want values for x to be bigger than 1. So I had to stop at 1. Notice I did have an arrow over here on the left, though. That's because on my t-table, I could have picked -5, -50, -500. It doesn't matter. You can pick whatever you want, as long as your values are less than or equal to 1. So that's why it goes off forever to the left. All right, let's do the second part. So my x values for this one are going to be greater than 1. And my y is going to be equal to whatever x is squared. Now, even though it says y is greater than 1, I'm still going to put 1 on it. But I'm going to remember that it's going to be open. So why does that make sense that I'd want to try 1?
You have to have a place to start your graph.
Yeah, exactly. You have to have a place to start. So basically, I could have picked 1.01, as small as possible, 1.00001. That would still work, right? So that's still greater than 1. But I don't want to put that on my chart. Yeah, so we're just going to know that we have an open circle. We have everything up until 1, but then it's open there. So 1 squared is 1. I also want to pick other numbers that are bigger than 1, so 2, 3, 4, different things like that. 2 squared is 4, 3 squared is 9, 4 squared is 16.
But you have to use like the same scale, right?
What do you mean the same
like
scale?
When you're drawing.
Oh, yeah. Use the same scale. Like if I'm going by ones, go by ones. So I have 1, 1, and it's open there. I I have 2, 4. Oh, did I go to 5? Yeah. 2, 4, 3, 9. And then way up there you have 4, 16. Okay, that's making a U shape because it's a parabola. Okay, and that's your piecewise function. Okay, so either method you want to use, like I said, usually people like the t-tables better when you first learn them. All right, let's try the next one. How about you guys try it first? So this one has 3 different pieces. So think about the 3 different pieces. So we'll do our 3 different t-tables. All right, so the first one is for x values that are less than 0. So you still want to put 0 on there, but just know that it's open. So 0 cubed is 0. Negative 1 is less than 0. So negative 1 cubed is negative 1. Negative 1 times negative 1 times negative 1. Negative 2 cubed is negative 8. So I should have 0, 0 is an open circle. I have negative 1, negative 1. And I have negative 2, negative 8. Right on the very end. Yeah, it's kind of like part of a parabola. The cubic function actually does this. Like it's part of a parabola and then part of a parabola. But the part we drew just looks like a part of a parabola. All right, 10. So it's 10 between 0 and 1. So 0 is less than or equal to x, which is less than or equal to 1. I'm going to put 0 and 1 in there, and I know they're both closed. So if y equals 10, that means y is always 10 between 0 and 1. So even at like 0.5, you still have 10. So Alex said, wow, that's a really tiny line. It's very tiny. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at the very top. Is that where it was? Mine is not calibrated very well. Hard for me to draw. It's right there. It's just a horizontal line between units 0 and 1. So x units. Yeah, so if I had y equals 10, you just go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you draw a horizontal line. But this is telling you that your x values are only between 0 and 1.
Oh, okay.
So the only piece of that you're drawing is between 0 and 1. So it's just real little.
Why would like a graph have different ones like that?
Why would it have something like that?
Like why would it have so many different pieces that are different?
It goes back to like the parking garage type thing. So if there's like something that you're paying for the taxes, it's a good example. So you want your taxes to have different pieces. Like people that make $40,000 and less don't get taxed as much as people that make like
their line is steep.
Yep. So the next one.
Be like a mix of curvy lines and linear.
It could be. Yeah. All right. Next one. So x and y equals 3x minus 1. This is when x values are greater than 1. So you still want to put 1, but know that it's open. Try 2 and 3 as well. So 1 gives me 2, 2 gives me 5, 3 gives me 8. Did you guys get all those numbers? Yes. Good. So 1, 2 is going to be open. 2, 5. 3, 8. That's a line, and it goes off forever to the right, so make sure you put your arrow. Does this pass the vertical line test? Yeah, because, yeah, it matches up at these 2 points, but one's open, one is closed.
So there's no empty space between them?
Yes, there could be. So the question was, could there be an empty space between them? Yeah, if I had said x is greater than or equal to 3 here, then between 1 and 3 I wouldn't have anything. So that can happen. Yeah, Monica?
Do you have like 2 dots on the same point?
Nope.
No?
Not 2 filled-in ones. You can have an open.
No.
Oh, okay. Could you have an open and a closed?
Yeah.
Okay, Monica asked, can you have an open and a closed on the same point? Yes, because then that closed one would just fill in the open one. Does that make sense? So you could have a piece that comes in and is open there, and then another piece that comes in and is closed there. Now that point's now been filled in.
So that
So
point
that
would
can happen.
work.
Yep.
But it wouldn't work for the left piece, but it would work for the right piece.
So then we fill it out. All right, number 3, evaluate each piecewise function for x equals -1 and x equals 4. All right, so you don't actually have to sketch these. Just think about it. Guys, you with me? We're almost done.
I'm with you.
All right, so if x is equal to -1, where is x equals -1? Is it in the top function or the bottom one? Am I using the top or the bottom? Top. Do you guys see it? If x is less than or equal to 0, x equals -1 is there. So that means you're going to use 3x minus 5 to find it. So for f of -1, I'm going to plug into the 3x minus 5. So I'm going to have 3 times -1 minus 5, so I get -8. For f of 4, what's f of 4? Bottom. See how x is greater than 0? X equals 4 is here. They won't always be in opposite ones. They could come from the same one. So I'd get 4 squared plus 1, so I get 17. So then if I asked what f of 5.5 is, well, you would use the same, you'd use the x squared plus 1. So you could use one of those pieces more than once. On your homework, there's one where you only use one. You have 3 pieces, but you only use one for both answers. So keep that in mind. All right, next one. So f of x equals 2x minus 1 if x is less than or equal to -1. Okay, in this one, -1 is there. In the bottom one, that's where x equals 4 is. Like I said, that won't always happen where you use both pieces. So f of -1, you use the top function, 2 times -1 minus 1, so you get -3. For f of 4, you use the top function, 5 times 4, so you get 20, or the bottom function, did I say top? So you get 20.
Write it in order pair.
You can, those represent points, but you don't have to. Usually if it's in function notation, you leave it like that, like f of -1 equals -3.
What if x equals?
What if x equals what?
Shine.
Oh, good question. What if x equals like 0?
Or no, what if like x equals 2 and x equals 4?
Yeah, okay, so the question is what if x equals 2 and what if x equals 4? Then they both come from the bottom one. So f of 2 would be 10, f of 4 would be 20.
You just like throw out the.
Yeah, you wouldn't worry about the top one. What if x equals 0 in part B?
Then it doesn't have anything.
Yeah, then that point doesn't exist. Do you guys understand that?
Yeah.
Hello? Stop packing up. You still have 3 minutes. I'm not letting you out. So if I said f of 0, that doesn't exist. That's not in either domain. So you would just write that point does not exist or something. Okay. You could say no solution. Maddie, did you have a question?
Where did they use 4 from?
It asked in the directions. It said find for x equals -1 and x equals 4.